Before we talked about how Kw, which is 1 times 10 to the negative 14, is equal to the concentration of the hydrogen ion multiplied by the concentration of the hydroxide ion. Now what we're going to do is we're going to talk about what pH is. pH is the negative log of the hydrogen ion concentration. Now, if you are taking Algebra 2, you might have started learning about logs. If you're not in Algebra 2 yet, you have not seen what a log is. However, I will show you how to type that in on the calculator. Essentially what a log is, though, is it tells you to what power of 10 a certain number is. And so we deal with numbers such as this. And to make this into a more manageable number, something that maybe is a little bit more relatable, we can take this number, plug it into this equation, and it'll give us some more manageable number, which happens to be 11.6. Now, what you need to know from this is that if you are given a concentration of hydrogen ion, we can calculate the pH from that. If we're given the concentration of hydroxide, we can calculate the pOH. So this we can use to calculate the pH, and this we can use to calculate the pOH. Now, the other equation that's on the bottom here, we can use to calculate pH and pOH if we're given one or the other, because those two added together happen to equal 14. And if you take a look here, there's this flow chart, and we can go around and around and around in the circle there. But if we're given one of these, let's say hydroxide ion, we can go anywhere we want. We can calculate the pOH, we can calculate the pH, and we can calculate the hydrogen ion concentration. And so we're going to use these equations here to help us calculate different parts of this flowchart here. Now, something to keep in mind is if you have a pH that is less than 7, it's going to be acidic. And if you have a pH that's greater than 7, it's going to be basic. And if you have a pH that's equal to 7, it's neutral. So if the pH is equal to 7, it's neutral. Now, this first problems here, problems 1 through 9, is asking if it's an acidic, basic, or neutral solution. And so I relate this to pH, although you can relate it to pOH as well, but I relate it to pH because most people might have a familiarity with pH. And so if we can figure out what the pH of the solution is, then we can figure out what the if it's acidic or not. So let's go ahead and talk about number 1 here. We're given a hydrogen ion concentration of 2 times 10 to the negative 4. And we can use our equation, negative log of the hydrogen ion concentration is equal to pH, to figure out what the pH is. So all we need to do is take this value and plug it into that equation. Let me go ahead and show you how you will type that in on the calculator. So on the calculator, if you take a look, again, it's the negative log of the concentration of the hydroxide ion. And so what you're going to do is you're going to type negative log, and then all you do is type in whatever the hydrogen ion concentration is and hit enter. And it's that simple. So again, you just type in negative log, whatever this is, and enter. So when you do that for number 1 here, the negative log of 2 times 10 to the negative 4, it ends up giving you 3.6989, which will end up rounding up to 70. Now, this happens to, when it comes to sig figs, the number of sig figs in the hydrogen ion concentration will tell you the number of decimal places. So because we have 3 sig figs, we're going to have 3 decimal places. Now, this is 3.700, which happens to be less than 7, so this happens to be an acidic solution. Now, we're going to go ahead and do the same thing for the next one. And that's going to give us 9.367, which happens to be greater than 7, which means it's basic. Now, for this next one, if we were to take the negative log of it, it does not give us the pH, but rather it gives us the pOH. Because the negative log of the hydroxide ion concentration gives us pOH. So if we were to type that in the calculator, we end up getting 6.009 for the pH. I'm sorry, not the pH, the pOH. But again, how are we supposed to determine if it's acidic or basic? Well, I gave you the rules for pH, so what we can do is we can use this equation to figure out what the pH is, because we know that the pH plus the pOH, which in this situation is this, is equal to 14. So the pH is equal to 7.991. And because it's 7.991, which is greater than 7, that means that this is a basic solution. Now what I'm going to go ahead and do is I'm going to just say if it's acidic or basic on the rest of these. And that's the answer to those. So you can pause the video real quick and work through those problems. Now for this next one, what we're going to do is determine the pH and the pOH of the following. So I'm going to do 10 and 11 with you, and then you can do 12 and 13. Now notice what this is giving us. This is giving us 3.14 or 3.41 times 10 to the negative 2 molar solution of HCl. If we were to take the negative log of that, is it going to give us the pH or is it going to give us the pOH? It's going to give us the pH, because what is this? This is an acid, and when this dissociates in solution, it's giving off a hydrogen ion. And so that means that whatever the concentration of this is will happen to give us the concentration of that as well. So we can take our 3.41 times 10 to the negative 2 and plug it into our negative log equation, our pH equation, and that will give us the pH. And the pH happens to be 1.467. I just want to pause real quick and show you how this number will always be close to this number, whatever this exponent is. And so that's just a side note, that whatever the pH is always going to be close to whatever the exponent is in the molarity of the hydrogen ion. So now that we have the pH, what's the pOH? This is equal to pH. Well, we can use this equation right here to calculate what the pOH is, because we know that the pH plus the pOH is going to be 14. And that will give us a pOH of 12.53. So let's go ahead and skip to 14 here. If you take a look, this is going to be the concentration, the molarity of sodium hydroxide. Now, if we were to take the negative log of this, is that going to give us the pH or is it going to give us the pOH? It's actually going to give us the pOH, because when sodium hydroxide dissociates in solution, we get a sodium ion plus a hydroxide ion. And so whatever the concentration of this is going to give us the concentration of that. And so in this situation, when we take the negative log of that, it's going to give us the POH, not the pH. The answer we get when we take the negative log of 3.75 times 10 to the negative 2 is 1.426. Again, notice how this number is close to that exponent. Now to get the pH, all we need to do is, again, use this equation up here to give us the pH. Now, notice how we're dealing with a base here. What is the pH of this solution? The pH of this solution is 12.574, which is greater than 7, which is a basic solution, which makes total sense. Now I want to talk about number 15 for a moment, because we're given this concentration right here, which again, when we do some sort of calculation with that, it's going to end up giving us the POH. However, when strontium hydroxide goes into solution, it dissociates to make strontium plus hydroxide. But it doesn't just make one hydroxide, it makes two hydroxides. So what does that mean for the concentration of the hydroxide? Well, whatever the concentration of this concentration is going to be double whatever that is. So if we have a concentration of 1.27 times 10 to the negative 3, and that's the concentration of strontium hydroxide, that means we'll have double the concentration of the hydroxide. And it is this number that we plug into our equation to get the POH. And that will give us 2.54 times 10, or 2.595 will be the POH. We can then take this, which again, this is the POH, and we can then subtract that from 14 to give us the pH, which is 11.4065. So just remember that to keep an eye out for this situation where whatever this concentration is, our hydroxide ion concentration will be double that because of this too. Let's go ahead and talk about problem number 17, 18, and 19 here. Number 17 is asking us to calculate the hydronium ion concentration. Well, if you take a look here, this is giving us the concentration of HCl, and we know that when this goes into solution, it's going to dissociate into hydrogen ion plus chloride ion. And so whatever this concentration is going to be the concentration of that as well. And so this right here happens to be the answer for number 17. The answer for number 17 is 1.57 times 10 to the negative 4. Now what I want you to do is, I want you to pause this video, and I want you to actually think about how do we go about solving number 18. And what I'm going to do is I'm going to bring us back to our flowchart to think about this. And so again, we're given the hydrogen ion concentration, and it's asking now for the hydroxide ion concentration. So looking at this flowchart, how can we go about figuring out the hydroxide ion concentration? And so again, pause the video for a moment, think about this flowchart, and then think about how you would solve for that. Well, we're given the hydrogen ion concentration, and it's looking for the hydroxide ion concentration. So what we're going to end up using is our Kw expression. And the reason why we're using that is because if we ever have one of them, we can always calculate the other one, because we know that Kw is 1 times 10 to the negative 14. Then we can plug in this value into this equation. Then we can use some simple algebra to solve for the hydroxide ion concentration. And then we can just plug this into our calculator to figure out what the hydroxide ion concentration is. And we end up with this as our hydroxide ion concentration, 6.37 times 10 to the negative 11. Now, is this acidic or basic? Well, again, there's two ways of knowing. First off, what are we putting in the solution? We're putting an acid into the solution, so it's going to be an acidic solution. But we can look at the hydrogen ion concentration and the hydroxide ion concentration. The hydrogen ion concentration is greater than the hydroxide ion. Because the hydrogen ion is greater, that means it is acidic. Now for numbers 20 through 22, if you take a look, this is giving us the concentration of calcium hydroxide. Now because this has hydroxide in it, we can get the hydroxide ion concentration. But what do we need to keep in mind? We need to keep in mind that for every 1 calcium hydroxide, there's 2 hydroxides. So that means that whatever this concentration is, we're going to have double the amount of hydroxide ion concentration. And so again, for every 1 of these, you're going to end up with 2 of those, so you're doubling the concentration. And what we end up with is 2.00 times 10 to the negative 4 molar solution of hydroxide. And if you do the math on the rest of it, there's your answers for those. Now, for your practice problem, I want to talk about how you go about solving this particular problem. I'm going to go ahead and just kind of give you a flow chart, and I'm going to give you the answer, and you can try on your own. But we need to think about what is it giving us, and what is it asking for. It's giving us the pH, and it's asking us to calculate the concentration of the aluminum hydroxide. Now, there's a couple things we need to keep in mind. Aluminum hydroxide is going to be Al. Aluminum is a 3+, hydroxide is a 1-. So that means we're going to have 3 hydroxides here. And this pH gives us the concentration of the hydrogen ion concentration. Or it gives us the concentration of the hydrogen ion. But this has hydroxide. So the first thing we need to do is we need to figure out how can we figure out the hydroxide ion concentration. Well, let's go ahead and take a look here. It's giving us pH, and we somehow need to find the hydroxide ion concentration. And so you can see there's a couple things we can do. We can go from here to here, and then up to here, or we can go this way. And it does not matter which way you go. But something that I'll say is, whenever you're going up this way, what you need to do is you need to take this equation and solve for the hydrogen ion. And in this situation, if you were to go from the POH to the OH, you would need to solve for the OH. And the way you do that is the following. 10 to the negative pH will give you the H, the hydrogen ion concentration. P to the 10 to the negative POH will give you the hydroxide ion concentration. And so this equation is the same thing as this equation, except for it's solved for this. And then same thing with this. This is the same thing as this equation, except for it's solved for that. So we can take pH, we can convert it to POH, because we know pH plus POH has to equal to 14. Then what we can do is we can convert this to OH, and in this situation here, what we use is we use 10 to the negative POH will give us the hydroxide ion concentration. But once we get this, we're still not even done, because the question is not asking for this. The question is asking for this. And what we need to keep in mind is we need to keep in mind that when this goes into solution, it's going to produce aluminum plus 3 hydroxides. So what I want to do is kind of give you an example. What happens if we had 9 of these? How many of these would produce 9 of these? Well, for every one of these, it's producing 3 of those. So that means 3 aluminum hydroxides would be required to produce 9 of those. The reason why I bring this up is notice how to go from here to here, we have to divide by 3, because look at the mole to mole ratio. It is a 3 to 1 ratio. Because the mole to mole ratio is a 3 to 1 ratio, whatever we get with this, we need to multiply it by 1/3 to get this. And the final answer is 6.7 times 10 to the negative 5. If you have any questions, the key will be on my website for these other practice problems. And feel free to email me, and I will respond with whatever answers I can.